Hi everybody, this is Mrs. Baxter, and today we are going to continue our discussion of greatest common factor and doing some factoring using the distributive property. We may not get into factor by grouping. So as a review, yesterday I went through greatest common factor using that T-chart, and you should have gotten a copy of the kind of T-chart cheat sheet for yourself. It should be in your folder. So if you haven't gotten that, please go get that right now because you're going to want to use that as your helper here. Okay, so as a refresher, greatest common factor, we're trying to find the two common factors between two products, okay? But there's some other things that you need to be aware of. So I'm sure you guys have heard of a prime number, and a prime number is an integer, or it's a number. So let's write, I'm going to use a different color here. It's an integer, which is another name for a number that only has the divisors of 1. So I'll write 1, but it's really the number 1 and itself. So, for example, a prime number would be the number 3. There are no other numbers that we can multiply together except 1 times 3. Same for the number 5. Same for the number 7. The number 11, and the number 13. And if you look at that cheat sheet that I give you, you're going to notice that those numbers at the top, when you look at the 3, 5, 7, 11, and 13, you'll only see two factors. You'll see 1 and the number itself. And anytime you see a 1 and a number by itself, you'll know that that is a prime number. Now, a composite number is an integer whose divisors are more than just 1 in itself. So basically, all the other products or the numbers that you see, so example, 4. Well, that's 1 times 4, but also 2 times 2 makes 4. 9 is another one. 1 times 4, but also 3 times 3. 20, look that up on your chart. Yeah, that's got quite a few, right? So 1 is a factor, 2 is a factor, 5 is a factor, 10 is a factor, and 20 is a factor. Same for, let's say, 60, and also 100. Like, all of those numbers are composite numbers because you will see multiple factors underneath their number in the cheat sheet, okay? The factoring cheat sheet. All right, so this is going to be a little bit different than what we did yesterday, but it's important, especially for when we get into radicals and breaking down all of these numbers into its parts. And you guys may remember doing something like this, maybe in elementary school or middle school. So let's look at the number negative 90. Well, I'm going to look at that and I go, okay, I can split that out, and feel free to write yourself a little, I'm not sure what's going on here, but write yourself like a little decision tree, okay? So that number is going to be negative 9 times 10. When I see the number 0, my first instinct is to divide it by 10, okay? 90 divided by 10 is negative 9. You can put that in your calculator. And then what we're going to do is we're going to break down each of these numbers. So negative 9, when I look at my factor tree, I can do negative 3 times 3, okay? And then when I look at 10, I can see 5 and 2. And I really, let's see, the only other thing I would do different is get rid of this now negative number and go negative 1 times 3. If you see a positive number, just leave it. okay? But we want to include that -1 in there. So when I add in all of my I'm trying to get this all down to my prime numbers, okay? So -1, 3, 3, 5, and 2. Now, the reason why I included this one, but not this one, is because we went ahead and broke it down further, okay? So you're going to go to the end of your tree on all of your legs and use those numbers at the end. So I've broken this down to -1. It's essentially saying -1 times 3 times 3 times 5 times 2. Those are all of my factors of -90. Okay, we can do that for 120 as well. Let's break this down. Well, let me just tell you too, there are multiple ways to break down some of these larger numbers. And it's okay because in the end, you are going to get the same numbers. Okay, so I'm going to go ahead and do 10 times 12. Again, how I said 0 right here, I'm going to divide it by 10 already. And then I'm going to go and break down my left side here. I don't know why it keeps doing that. And I've got 2 times 5. Here I've got, I could do multiple things. I'll do 2 times 6, but I can also break down 6 to 2 times 3. So here's all of my prime factors, okay? So this one is 2 times 5 times 2 times 2 times 3. So if you were to put all of these numbers into your calculator, you would get the answer 120. All right, on your chart, go look up number 11. What do you see? Well, if you see 1 times 11, this is prime. Okay. So again, moving down here to greatest common factor. Our greatest common factor is the greatest. I'm going to write this in a different way so that way you know the greatest or the biggest number that is a factor or also known as divisor of both original numbers. So let's do a quick example, okay? So an example would be find, and you're going to hear me say this a lot, find the GCF. GCF, greatest common factor. So I'm going to short it to GCF. Find the GCF of 20 and 48. Remember, yesterday we used that T-chart for both the numbers. Well, look on your cheat sheet for the number 20. Then hold your finger on 20 and then look at the number 48. Compare the factors listed under each of those numbers and find the number that is the greatest. And you're going to see that your greatest common factor is equal to 4 for those two numbers. If you didn't find that, please come find me, okay? And ask me or Mr. G how we got that. All right? All right, I'm going to get a little bit tricky here. We're going to start working with monomials to try to find the greatest common factor. I think you guys have how to get the numbers by now. All right, so first thing you're going to do is I want you to try to find your greatest common factor for your numbers. Do that first. And you're probably hearing my Lucy and Leo here. So find the greatest common factor for 36 and the greatest common factor for 54. Okay, what you're going to do, you'll find that your greatest common factor for both of those numbers is 18. All right, now we need to start comparing the actual letters. All right, so when I'm looking at my letters on this one right here, if it helps, I'm going to actually erase this here. If it helps, write it out and say I have x times y, okay? And on this one right here, I have x times y times z. Well, we're trying to look for the ones that are the same. So as I match them up, I go, ooh, I have an x and an x. That is a greatest common factor. So let me write that in a different color. I have one of these x's, okay? So I'm going to cross out an x. I have another x right here, but I don't see one over here. So that has to stay. All right, and then it doesn't count. It's not a greatest common factor. Then I have a y. I have one y here, so let me cross those out. Y, so times y. But I don't have another y to fill this one out, and I don't have a z in both of them. You have to have them in both. So the two variables that each of these terms have share an x and a y. So my greatest common factor is going to be 18xy. I think my pen's going bad. All right, so it's the same as 18xy. Excuse me. All right, let's look at 27a squared b and 15ab squared c. Excuse me. All right, I'm going to grab some water here in just a second. All right, go look at your table and try to find the greatest common factor for your number first and see what you get. If you look at your table, you're going to see a number that pops out that they both share. Hopefully, you said the number 3. So let's write that off to the side. 3 is the greatest common factor for both 27 and 15. Now I'm going to look at my letters. All right, in 27a squared b, I have 2 a's, but I only have 1 over here. So I can only take 1 as the greatest common factor, okay? Then I'm going to compare my b's. This has 1, this has 2. Ooh, I can only take 1 of them out, all right? They share 1b. Now my next question is do they share, let's see, a c? No, I don't see a c here. So my greatest common factor, my GCF, is just 3ab for each of these monomials. Let me see. Let me do another example that's just really simple. Let's look at, say, 10x cubed and 15x squared. Well, if I look at my table, what do you get for your GCF? If you look at your table, the number that's the greatest common factor for 10 and 15 would be 5, right? And when I'm comparing my letters right here, I can take 3 of them from here, right? But can I take 3 from here? No, I can only take 2. So you have to go with the smallest number when it comes to your variables. So these two both share 5x squared as my GCF. Okay, let's look at the distributive property. So look on the back of this sheet, and then we'll stop there. All right, so it looks tricky, right? We've added a plus sign. But all we're doing now is we're looking for a greatest common factor between 12a squared and 16a. Well, if I look at my table, I'm going to see, oh, the number 4, I'll do this in a different color. The number 4 is my greatest common factor. Okay, but here's where it gets a little different. All right, when I'm looking at my greatest common factor, I see, oh, yep, my greatest common factor is 4. What is it for my A's? Well, I can take 2 from this one, but I can only take 1 A from this one. So my greatest common factor is a 4A. But I want to know what's left over. Okay, so this is why I drew my parentheses here. Oops. All right, let me redraw that. So I figured out my greatest common factor is here. So if you need to draw yourself a note, write GCF, and it goes outside of your parentheses. But now I need to know what's left over. So as I'm looking at this, I'm looking, okay, 4 times what is equal to 12? Well, if you look at it, 3 is left over. And I only took one of these A's out from this first term. So I'm left over with an A. Okay? You're going to keep that plus sign. Now let's look at 16A. 4 times what number is equal to 16? Well, if you use your cheat sheet, you can see that 4 times 4 is 16. But are there any A's left over after I took out the A? No, there's not, because my A is now out here. It's a greatest common factor. So I've now created a new equation, 4A times 3A plus 4. If you were to go back and distribute this, you're going to get, if I was to go back and distribute this, like what we were doing earlier this week on your quiz, you're going to get this answer. So I'm teaching you to work backwards, pull out the greatest common factor right here for this, and tell me what's left over. Let's try another one. Okay, this looks trickier, but it's not. It's the same thing. The very first thing every single time you look at a polynomial is to look for the greatest common factor. So this time you're going to compare 18 on your cheat sheet with 12 and 9. Okay, so when I look at 18, 12, and 9 on there, my greatest common factor, the factor that they all share, that is the greatest, is the number 3. Okay, now we're going to have to go through and systematically look at our letters. This has a C, this has a C, this has a C. Okay, cool. So it looks like I can take out at least one C from here. I've got 1. I have 2 here, which tells me I'm going to have a leftover, but I'm going to take this C out too. All right, so I have 3C as a common variable between all 3 of those terms. And then now we're going to look at our D's and make a comparison. I've got 2 here. Ooh, but I only have 1 here and I only have 1 here. So the most I can take out is just 1 D. So 3CD is your greatest common factor. But what's left over? Let's look at our first term. I want you to figure out 3 times what number is equal to 18. If you want to use your cheat sheet, look at 18, okay? And in your cheat sheet, in your cheat sheet, you're going to see, 18. Well, what is one of the factors? It's going to be 3 and 6. So you're going to use that 6 is going to be left over right here. Okay, we took the C out, right? C's out. And we took 1 D, but we have a D left over. So you have to keep your leftovers on the inside of your parentheses. Now, I'm moving on to the next. So make sure you add a plus sign here. Let's look at this next term. 3 times what number is equal to 12 now? 3 times what is 12? 4. Okay. Greatest common factor, I took one of these away, so I'm left with 1 inside, but I don't have any D's because I took this D and moved it out there. So I'm done. This is it. All right, let's keep moving. Plus, now let's make a comparison. 3 times what number is equal to 9? Well, if you said 3, you'd be correct. And I want you to notice here I've got a C and a D, but look, I took those out as my greatest common factor. So I am left with just the number 3. I have nothing left. What I want to show you now is if we do that multiplying and we do the rainbow, what we're going to get in the end. Okay, so this is a way for you to double check that you did this correctly. All right, so let's multiply. Okay, 3 times 6 is 18. When I multiply my C's and D's here, I have 1 C, and now when I've multiplied, I have 2 D's. All right, look at that. 18CD squared, 18CD squared. I did that first term correctly. The next thing I'm going to add, let's multiply those two terms together. 3 times 4 is 12. Okay, and the C times C is going to be C squared. I have 2 of them. And D times this term, I can't forget it. I need to put it in there. Oops, D. Oh, look at that. C squared, 12C squared D, 12C squared D. Yay, check. Last term, let's multiply across. 3 times 3 is 9. And I can't forget my CDs. I'm going to put that here. And sure enough, these two terms match up. So this is our answer, right? But this was our double check when we FOILed it out. I'm going to go ahead and have a stop right there. There is a homework assignment. You're going to be mostly working on finding the greatest common factors in sets of monomials. Let's start there. We will review with the distributive property on Thursday and go from there. If you have any questions at all, please ask Mr. G or just do your best. I want you to start working on the odd problems. And if you get done with that and you find that easy, then go ahead and start working on the rest of the worksheet.